Gave you this inequality in two variables, x plus y is less than or equal to 10. Give me one solution for x and y here that would make this true. Now there's an infinite amount of solution. What's one of them? 5 and 4. I'd go with 5 and 4, right? Because that'd be 9, and 9 is less than or equal to 10, right? What's another one? 5 and 3. 2 and 1. 0, 5, 4 and 4, right? We could keep going on forever. We could start adding in decimals. We could start adding in fractions. We could start, well, there's an infinite amount of solutions here, right? What we're going to do today is figure out how can we represent all these solutions without listing them, because that would be impossible. Okay? How can we use two variable inequalities and write out all our solutions without listing them like this? Okay. Let's review graphing real quick here. So, when we were graphing, we had y-axis, x-axis, okay. And I would give you some equation like this that says, for example, y equals 2x minus 1. Okay. And that is in what form does it have to be in the graph, or what is that form? It's in slope-intercept form, right? Good. Okay. And then which of those numbers tells us our y-intercept?
1.
-1 does, right? The number without the variable. And then the slope is a number in front of the x. So it's up 2 over 1, right? We're going to go up 2 over 1 to the right. Do that a couple times. We would draw our line, put arrows on the end. There's our graph, right? That's we review graphing. Okay. So we need to know that in order to solve these two variable inequalities. So looking on your sheet there, let me pull back up another graph here. The first one says y greater than or equal to -3x plus 4. Okay. So that's your first inequality. And I want you to first graph it as if there was an equal sign in the middle, not an inequality. So I want you to graph it as if it was y equals -3x plus 4 on that one. So do that first. So you're going to go to +4 on the y-axis. You're going to go down 3 and to the right 1. And just get the best looking straight line you can. Doesn't have to be perfect for now. Okay. So we're going to graph it just like there was an equal sign there. This is called the boundary line. This is going to be the boundary for where all the answers exist. Okay. Now, what we want to do is, again, our goal is to try and figure out what can x and y be so that this top equation is true. Like, can anybody think of any off the top of their head? If we were plugging in y is this and x is this, how could we make that true? Again, there's an infinite amount of answers. Anybody have one of them? Like, for example, let's say if we plugged in 0 for y and 1 for x. Let's see if that's true, right? 0 greater than or equal to -3 plus 4. 0 greater than or equal to 1. True or false? False, right? So 0, 1 would not be an answer because 0 is not greater than that. So, anybody got any off the top of their head? It's a little bit harder to think about here, right? Let's say 3, 1. We plug in 3, 1. -3 plus 4. 3 greater than or equal to 1, right? That's one solution, right? Y is 3, x is 1. But again, there's an infinite amount of solutions. And what happens is all the solutions are either on this side of the boundary line or they're on this side of the boundary line. Okay? We don't know which one. We're going to have to pick a solution and test it. So we need to pick a point anywhere on the graph and plug it in here to see if it's true. Now, usually one point is a lot easier to test out than the others. What would be a really easy coordinate to plug in for x and y to test it out, like we just did? What's this coordinate? 0, 0, right? That's 0, 0. That's x is 0, y is 0. Let's test out this coordinate here in this equation. If I plug in 0 for y and 0 for x, I get 0 greater than or equal to, negative 3 times 0 is 0, plus 4. So I get 0 greater than or equal to 4. Is that true or false?
False.
That is false. So 0, 0 is not a solution to this inequality. So that means, because this is our boundary line, 0, 0 is not a solution. All the solutions are actually on this side of the boundary line. So what you're going to do after you graph this is you're going to lightly shade with your pencil the area or that region kind of on the right of that line, because all of the points in that region are the solutions. They're all the points that work for x and y. So you want to just lightly shade kind of the right side of this line, because everywhere there is all the solution. We call it solution region. For example, let's just randomly pick a point in that region and test it. Like, let's say this point, which is 3, 1, right? This point is 3, 1. So let's plug in x is 3, y is 1. It should be true since we shaded it. So we get 1 greater than or equal to negative 3 times 3 plus 4. 1 greater than or equal to negative 9 plus 4. 1 greater than or equal to negative 5. That is true, right? Every point in this region should be true, because again, that's what boundary means, right? Boundary means you can't cross it, or there's something happening on one side that doesn't happen on the other. This boundary line means all the solutions are on one side or the other of this line. And you just pick a point and test it, and if that point is true, you need to shade over it. If it's false, you need to shade the other side. Yes, question?
So we know which side it needs to be on by the arrow?
By testing it out. If once you test it out, the point we picked, we first tested was this one, and it was false, that means all the solutions are on the opposite side or the other side. We tested it out in this case, we tested this point and it was true, that means we need to shade the region. We always shade that region where it's true. Okay. We're going to do several of these days, so let's go on to the next one, okay, on number 2. I first want you to draw the boundary line on number 2. So you graph the line just like there was an equal sign there. Okay. And again, number 2 says y less than or equal to 3/5 x minus 5. So where are you going to start out on the y-axis? Negative 5. Okay. And since it's a positive 3, we're going to go up 3, because the top number tells us how much to go up or down. Bottom number tells us how much to go left or right. So we're going to go up 3 to the right 5. We're going to draw that boundary line there. So this is our boundary line. So it means on one side of this line are all the solutions to this inequality. On the other side of this line are all the non-solutions, or things that do not make it true. And the way we find out which side is which is we pick a point and test it. And 99% of the time, the easiest point to test is going to be 0, 0, because it requires very little work to test out the point 0, 0. Again, that's x is 0 and y is 0. So let's plug in 0, 0 to this inequality and see if it's true. 0 less than or equal to 3/5 times 0 minus 5. 3/5 times 0, we know is 0. 0 minus 5 is negative 5. Is this statement true? Is 0 less than or equal to negative 5? It is not, right? So that is not a solution. 0 is not a solution to this problem. So does that mean the solution region is on this side, or is it on the other side? It's on this side. So you would just lightly shade this region on that side of the boundary line. Okay. Now, when you're shading, you don't have to make sure every square inch is colored. You just need to shade it enough that we know that's the side where all the solutions are. Okay. Because technically this would go on forever. Right? This line would keep going over here, and we would keep shading this way, keep going this way, we'd shade this way. That's all the solutions. And if we wanted to, we could pick a point. Like if we pick the point 3, negative 5, that's that point right there. Since it's shaded, it should work if we plug it in. It should be true. Any point in the shaded region should make it true. Okay. All right, any questions at that point? All right, let's go to 3. 3 says y greater than negative x minus 5. So you're going to start with your boundary line. You're going to go to negative 5 on the y-axis. The slope, the number in front of the x, is a negative 1, so it means from that point we're going to go down 1 and to the right 1, or go up 1 and to the left 1. But this time, I want you to put a dashed line through here, and I'm going to explain why in just a second. Instead of making it a solid line, I want to make it a dashed line. Okay. Now, remember when we had an open and closed circle? When we had a closed circle or a filled-in circle, that meant that number was included. And when we had an open circle, it meant that number was not included. It's the very same thing with dashed lines and solid lines. For example, let's pick a point that's on the dashed line. This point right here. That's the point 0, negative 5, right? That's x is 0, y is negative 5. Let's plug that into this inequality and see if it's true. If I plug in negative 5 greater than, that's negative 0, which is 0. 0 is not positive or negative. So I get negative 5 is greater than negative 5. Is that true or false? That's false. It's not greater than. It's equal to. Right? So we put a dash line whenever the inequality symbol is a greater than or whenever it's a less than. Because that means any point that's on that line is not an answer. Only the points on one side or the other is a solution. So whenever it's a greater than or less than, it's a dashed line. Whenever it has the or equal to symbol under it, it's a solid line, because that means the point on that solid line is included. It makes it true. So we have to figure out which side of this line are all the solutions. Okay. Again, the easiest point to pick usually is 0, 0, when x is 0 and y is 0. So let's pick that point and plug it in. 0 greater than 0 minus 5. 0 greater than negative 5. True or false? True. So does that mean I need to shade over 0, 0, or I need to shade the other side? I need to shade over it, because that's my solution region. We always shade the region that make it true. So you would shade kind of the top right of that line. Okay. And every point in that shaded area makes this true. Every point that's not in that shaded area makes this false. So just by looking at this graph, if I told you, without doing the actual work, if I told you the point 1, 3, would it make this true or false? True. It would make it true because it's in the shaded area, right? Or if I told you the point 100, 100, would that be true or false? True. It'd be true because it would be in the shaded area, right? It'd be way up there. Okay. If I told you the point negative 50, negative 50 would be false because it'd be way down here, not in the shaded area. Now you could always test those points and plug them in, but that's what our boundary line helps us do. Okay. Does that start to make a little more sense?
The one thing I was a little confused about, you said if it's greater than or less than, it's a dotted line?
If it's dotted line.
But then this one's not greater than less than.
This one's just greater than, so we made it a dash line. Yeah. Okay. Whereas the first two, since it had the or equal to under it, made it a solid line, because that means the points that lie on that line are included in the answer. Okay. All right, let's go to 4. This one just says y greater than negative 4. Now that means there's a 0x slope, or the number in front of x is 0, they just didn't write it. So when you have a 0 slope, what type of line is that? Horizontal, very good. So that means you need to go to the y-coordinate. Remember we treat it as if there was an equal sign there? We go to the y-coordinate at negative 4, and we're going to put a horizontal line through it because there's no slope, there's no x, it's a 0x. But is it going to be a dashed line or a solid line? Very good. It's going to be dashed because it's just greater than. Because let's think about it. If you plugged in this point, 0, negative 4, there's no place to plug in x, but if you plugged in y is negative 4, you'd get negative 4 greater than negative 4, which is false. That means the points along this line are not included. So then we have to figure out, do we want to shade above this line or do we want to shade below this line? Again, we can pick out a test point, But it says y greater than -4, so it wants all the y's that are greater than -4. Do those y's lie up there, or are they beneath it? They're above it, right? That's -3, -2, -1, 0. If you needed to, pick 0, 0 as your test point. If you plug in 0, that's true. So we would shade above that line. All of those points in that shaded area make this true. Okay. Go ahead and try 5 and 6 yourself, and I'll come around and answer questions or check it, and then I'll put the answers on the board for you to check. So there's number 5 in blue. Should go through -5 on the y-axis, should go up 2 to the right 1, and you should shade on the left side of that line, because if your test point was 0, 0, that makes it true, so you need to shade over 0, 0 side. Okay. So that's number 5. So number 6 should look like that. Should be a solid line, goes through 2 on the y-axis. And on the left, should shade the left side because 0, 0 is not a solution, so you would shade the other side. Okay. How do you feel about those? All right?
Great.
Good. That's the solution region. All right, flip over to the back. This one's a little different in that it just has an X and doesn't have a Y. Okay. There's only an X, not a Y. Very good. When it's just an X and not a Y, that means it's a vertical line through that X coordinate. You treat it as it's this. So you're going to go to -5 on the X-axis and put a vertical line. Now is that vertical line going to be dashed or solid?
Dash.
It's going to be dashed because it's just less than. Very good. And then we have to figure out, are all the solutions on the left side or are all the solutions on the right side? And we can just pick 0, 0 again if we want. You can pick any point. That says that 0 is less than -5, which is false. So you don't want to shade over 0, 0. You need to shade on the other side of your boundary line. So it's going to look like that. Because that makes sense, right? If you plugged in -6, -7, -8, all of those for X, it would be true. I've had a couple good questions. That in this case, 0 less than or equal to -4 is false, though, because 0 is bigger than -4. So it means that is not a solution, which means you need to shade on the other side of the boundary line, so you'll be over there. Okay. What is different about this one versus the ones we've been doing? Every variables are on the same side. Y is not by itself. It's not in slope-intercept form, right? So we need to get it in slope-intercept form. We need to get y by itself before we start graphing here. So the first thing we're going to do, because remember the number closest to the variable we save till the end, we first need to move that 3x to the other side of the inequality. And just like an equal sign, to move a positive 3x to the other side, we can just subtract it from both sides. So on the left side then, I'm left with -2y. Nothing happened with the sign. And on this side, I'm left with 10 minus 3x. Again, I didn't subtract these because they're not like terms, right? If it was 10x minus 3x, it'd be 7x. But since it's just 10 minus 3x, they don't both have the same variable. I just leave it. Finally, I have to undo that multiplication by -2. So I'm going to divide by -2. But remember, when you multiply or divide on one side, you have to do it to everything on the other side. So when I do that, I'm going to be left with 1y on this side. But I divided by a negative on both sides. So what's going to happen to that symbol? We're going to flip it. Because when we multiply or divide by a negative number, the sign flips. So we flipped it. 10 divided by -2 would be -5. And then we have a -3 divided by -2. Now that would be 1.5, but we don't want to deal with decimals in a slope, so we're going to leave it as a fraction. But since it's a negative divided by a negative, that's going to be a positive. So we're going to make it a positive 3/2 x, or 3/2x. Okay. So that means this is in slope-intercept form. They just wrote our y-intercept first, the number without the variable. So we're going to go to -5 on the y-axis. And then our slope is up 3, to the right 2. And is it going to be a dashed line or a solid line? Dashed line because it's just greater than. One way you can remember it is if it has a solid line underneath it, meaning the or equal to, it's solid. If it doesn't have a solid line underneath it, it's dashed. Okay. And then finally we have to figure out on which side are all the solutions. Are they on this side or are they on this side? We can do that by picking our test point 0, 0. We can plug it into either this one or this one. Doesn't matter. Let's plug it in the bottom one. We would get 0 greater than -5 plus 3/2 times 0. 3/2 times 0 is 0. And I get 0 greater than or equal to -5. True or false? True. 0 is greater than or equal to -5. So that means this is a solution, which means it needs to be in the shaded area. So I'm going to shade that side of that line. So the difference in this one is you had to put it in slope-intercept form first before you could do anything else to make your boundary line. Remember, if you multiply or divide by negative, the sign flips. The inequality symbol flips. So just like the previous one, this is not in slope-intercept form. We have to put it in slope-intercept form. So we'll start by moving that positive 5x to the other side. That's going to leave me with -3y. Less than or equal to -15 minus 5x. I then need to get rid of that multiplication by -3. So I will divide everything by -3. That's going to leave me with 1y. Positive 5 because it's -15 divided by -3. And then this does not simplify into an integer. So I'm just going to leave this as a fraction, but it's a negative over a negative, so I'm going to make it a positive 5/3 x. And what about my symbol, or inequality sign? It's going to flip since I divided by a -3. And then I can either go up 5 to the right 3 or down 5 to the left 3, because that's like negative over negative. And it's a solid line because it's or equal to. And then I'm going to pick a test point. Again, we'll continue to pick 0, 0. (5/3 times 0, which is 0. So I get 0 greater than or equal to 5, which is not true. That's a false statement. So that's not part of my solution region, which means the other side is. If you ever want to be really sure, you can just pick a point that's in the solution region and plug it in, and it should be true. But again, the reason we pick 0, 0 because it goes really fast. You don't have to worry about multiplying fractions here, because you know a fraction times 0 is going to be 0. Again, not in slope-intercept form. So to get y by itself, we'll start by moving that x over. Leaves me with -y greater than 2 minus x. But I don't want to deal with -y. This is like what number in front of the y? -1. So that's like -1 times y. So to undo -1 times, we're going to divide everything by -1. So that's going to leave me with positive y. But since I divided by a negative, flip that. 2 divided by -1 is -2. And then it's -1x divided by -1. Negative over negative, positive 1x. So then we'll go to -2 on the y-axis. Our slope is up 1 to the right 1. And will it be dashed or solid? Dashed because it's just greater than. Means every point on that line is not included. So then I figure out which side are all the answers. Let's plug in our test point, 0, 0. 0 less than -2 plus 0. So 0 is less than -2, which is not true. 0 is greater than -2. So that is not part of our solution, which means the region is on the other side of that line. And that's it.